video, we're going to be returning to the idea of repetition structures, or for loops and while loops, and looking at nested loops and the break statement. So what do we mean when we talk about a nested loop? Well, basically a nested loop is just a loop that runs inside of another loop. So when would you want to use a nested loop? You may want to use it, for instance, when you're performing the same set of operations on a bunch of different data sets. So you may have one loop that performs your set of operations. You would have then another loop that feeds in different data sets to that set of operations. You may have a set of computations where you're using multiple independent variables. So for instance, you might do this in a situation where you're trying to determine what the effect of different variables have on some type of computation, or maybe a model or a simulation. So you would have a different loop that changes the value of different variables. So as you go through, you can actually test all the different possible sets of input variable values. And the one that's most common, which is why we're starting to talk about nested loops right now, is when you're working with two-dimensional arrays. So let's start off with the for loop. Here we can see an example of a nested for loop where we have an outer for loop, and as part of the code that's being performed inside that outer for loop, we have another for loop. Okay, so this would be a situation where we have nested for loops. Okay, so we start off with our outer for loop. It has its own separate variable, has its own separate start, increment, and end. And then there are MATLAB statements, which can occur before and after our inner for loop, which has, again, its own separate variable and start, increment, and end, and some MATLAB statements that are specific only to that inner for loop. So when we're using nested for loops, our loop control variables, in this case variable 1 and variable 2, have to be different. Okay, if they're the same, then they can start to get confusing about which variable is acting where, and MATLAB can have some issues with that, as well as you when you're trying to figure out what to do. Okay, so you have to have different variable names for the variable for your inner for loop and for your outer for loop. And how this works is that for every iteration of the outer for loop, the inner for loop is going to go through all of its iterations. Okay, so we'll take a look at an example here in a second so you can see what this looks like. So here we have an example of a nested for loop structure, which is going to go through and create your multiplication tables for the values of 1 through 5. Okay, so if you remember back to when you were first learning about multiplication, you can have the multiplication table, which has kind of 1 through 10 on the top and 1 through 10 down the side, and then each value in the grid corresponds to a number on the left multiplied by a number along the top. Okay, so we can do the same thing here in MATLAB. So we have a nested for loop. We have our outer for loop has a loop control variable of n. Our inner for loop has a loop control variable of n. Okay, they're both going to go from 1 to 5, incremented by 1. Inside our inner for loop, we have an fprintf statement, which displays a number times a number equals a number. The values that are going to display are the loop control variable m, the loop control variable n, and then the product of m times n. And then after we finish that inner for loop, we have an fprintf statement that moves us down to the next line. And then we repeat the outer for loop. So if we were actually to run this, and you could copy this code into MATLAB and run it yourself to see how it works, okay, the first thing that we would see, we would enter the outer for loop, the value of m would be 1. We enter the inner for loop, the value of n is 1, and then we execute that fprintf statement. So we get 1 times 1 is equal to 1. Now the inner for loop iterates, so n becomes 2, m is still 1, so now we have 1 times 2 is equal to 2. We continue 1 times 3, 1 times 4, and then 1 times 5. At that point, we've now finished execution of the inner for loop. We perform the fprintf statement, which moves us down to the next line, and now we iterate the outer for loop. So now m becomes 2, and then we repeat this whole process. So now we have 2 times 1, 2 times 2, 2 times 3, 2 times 4, and 2 times 5. Okay, so that would be then the second time through the outer for loop, and we've actually gone through the inner for loop twice, because we go through that inner for loop for all of its iterations every time we go through the outer loop once. So if we were to continue this process, we would have 3 additional lines where m becomes 3, then 4, then 5, and as we're going along these columns, we increment n every time we go through the outer loop once. So here we have another example of a nested for loop structure, but we're actually using it with a two-dimensional array. This is probably one of the most common instances where you would use nested for loops, and one that you'll probably see a lot throughout this course. So here we have an array called data, which is a 3x3 array, and it has the numbers 1, 2, 3, 4, 5, 6, and 7, 8, 9 in its 3 rows. Alright, so we know the size command will give us the number of rows and number of columns for data. We then have two variables, sum and count. Essentially what we're going to be doing is calculating the average of the numbers that are included in this array. So we have, again, two for loops, one inside the other. The outer for loop is going to allow us to go through the rows. The inner for loop is going to allow us to go through the columns. So you can see inside the inner for loop, we're simply adding up each data point from that array, and the outer loop, and then the count statement keeps track of how many times or how many values we've added onto our sum, so that at the end, with the fprintf statement, once we've gone through each row, so we would start out, it would be sum equals sum plus 1, then sum equals sum plus 2, sum equals sum plus 3, and so on. Then we would move down to the next row, sum equals sum plus 4. We'd ultimately end up with the sum of our values we divide by the number of values we have and display it in the fprintf statement. So if you were to copy this set of commands and run it in MATLAB, what you would end up with is that average is equal to 5. So just like we had nested for loops, you could also have nested while loops. It would look like pretty much the same structure, right? Except now instead of for loops we have while loops, and instead of counters we have conditional statements. So we have while condition 1, and we can have some MATLAB statements inside there. We also have then a second while loop inside of our outer while loop, which has its own separate condition. So when you're nesting while loops, the loop control variable or variables that you use in your conditions can be the same or they can be different. Okay? So for instance, you might want to have some condition that occurs that causes both of these loops to exit. So maybe it's like an error condition or something like that. You could have a variable that you use in the condition for both the outer while loop and the inner while loop that cause them both to exit, so that it would then exit out of this process and you could continue on with the rest of your program. Okay. The conditions themselves can actually be the same or different. In most cases they're going to be slightly different, but they might have some similarities, especially like in the situation I just mentioned, where you would probably have at least one part of that condition that is the exact same for both of them if you had some type of error command that you wanted to exit out of both loops. So here's an example of where you would use nested while loops. So this is the game you probably played it since you were 5 years old, where somebody thinks of a number and then the other person has to try and guess that number. Well, instead here, the computer is going to think of a number, and then you have to try and guess the number that the computer is thinking of. So you can see we have nested while loops. The outer while loop allows you to play this game multiple times. The inner while loop controls the actual guessing portion. Okay? So while repeat is 1, so that says that we want to repeat the game and play again. Then we have a line which creates a random integer, and that the user's initial guess is 0. Okay, so the random number in this case is going to be between 1 and 10, which means that a guess of 0 allows us to enter the inner while loop because the computer's number cannot be 0. Okay, and you can see that our condition is, well, the guess is not equal to the computer's number. So inside there, it asks the user to enter, inside the inner while loop, it asks the user to enter their guess, and then checks to see if the value that the user typed in is the same as the value that the computer generated. If it's not, it says try again, and you would continue this process in this inner while loop until the user types in the value that the user types in the value that the computer had generated. Once that occurs, then it says you exit the inner while loop, you get the fprintf statement, you found my number, there's a menu statement, do you want to play again? If you click yes, that makes the value for repeat 1, so you would repeat then the whole process of that's inside that outer while loop. So it would generate a new number and then go through the process of having the user enter values until they get it correctly. If you click no, then the value of repeat would be 2, and it would cause that outer while loop to exit and thus end the script. So you've seen that you can have nested for loops and you can have nested while loops. Well, you can actually nest for loops inside of while loops or while loops inside of for loops. Okay, this gets a little bit tricky because you have to pay attention to which type of loop is doing what. Especially with the for loop, it's going to keep track of the loop control variable automatically, whereas the while loop, you have to make sure that you're keeping track of the loop control variable. Okay. So as an example of when you might want to mix and match these, you could, for instance, be trying to read in lines from a file. So you don't necessarily know how many lines there are inside the file initially, so the process of getting the lines would be a while loop, right? You don't know ahead of time when you want to stop that process. However, you can get, once you get a line out from the file, you can check to see how many characters there are inside that line. For that, you can then use a for loop if, for instance, you want to go through and count the number of A's that occurred within that line. Okay? So you have the while loop, which is going through and getting lines out of the file, and then inside the while loop you have a for loop which counts every character that is an A inside, or checks every character in that line of text that you read in from the file and checks to see whether it's an A or not. Okay? So while loop to get the lines, for loop to count the number of characters, because once you have the line, you can easily determine how many characters there are. Alright, so one last thing about nested loops before we talk about the break statement. So we could also have what we would call contingently nested loops, where the operation of one loop depends on the current state of the other loop. So in this situation, you can see that we have nested for loops, but the current value of the loop control variable of the outer loop, m, is going to determine how many times the inner for loop repeats. Right? We can see that in the statement for the inner for loop, we have n equals 1 colon m, which means we're going to repeat for whatever the value of m is. So in this case, if you were to look what happens, so m starts out at 1. The first time we're going through the outer loop, the inner loop only goes through once and displays a single asterisk. Then we repeat, m becomes 2. The inner for loop then repeats 2 times on the second iteration of the outer loop, then 3 times, 4 times, and 5 times. So if you were to go through and do this, we'd have 1 asterisk on the first time through m, or through the outer loop, 2 asterisks the second time, then 3, and then 4, and then 5. Okay, so this is a situation where one loop is going to depend on the state of the other loop in order to produce this triangular output pattern that we see here. So the other thing we need to talk about in this video is the break statement. So the break statement allows you to force MATLAB to terminate whatever loop that you're currently inside of. So as an example, we have this simple script here, just a single loop, a for loop. It's going from 1 to 20, but inside we have an if structure which includes a break statement. So what this is going to do is, if that condition within the if structure is true, so if 2 minus the sum is less than 0.00001, or 1 e to the minus 5, then we're going to force the loop to stop before it reaches the value of k equal to 20, which would be the last time it would repeat. Okay, so as we go through and we do this, so sum is equal to 1 initially, so we'd have 1 plus 1/2, so that would be 1.5, then we'd have 1 plus a quarter, then 1 plus an eighth, and so on. So you would eventually reach the point after the value of k equal to 17 when 2 minus the sum is less than 0.0001, and the loop would actually stop before it reaches the value of k equal to 20. We would actually stop when k is equal to 17. Okay, so it's a way to force a for loop predominantly, but you could use it in a while loop as well, a way to force a loop to stop if something occurs where you can't continue on with the processing of the loop. So bringing these two ideas together, there's a little bit of a tricky thing you got to pay attention to if you're using break statements inside of nested loops. And that is that the break statement will only affect the loop in which it is directly associated with. Okay? So as an example, here we have nested for loops. It's going through and doing something. You can see that inside the inner for loop we have a break inside that if structure. So if the value of x times y, which is the value of the outer control variable times the inner control variable, is greater than 9, then we break. In this case, we can see that this break statement is included in the code for the inner for loop. So when that break statement occurs, it'll force the inner for loop to stop, but the outer for loop will continue to go. So let's see, what's the first value that it would occur? Probably when x is 2 and y is 5. So when y is 5, it would actually break out of that loop, but then x would increase to 3, and we would actually go probably till y equals 4, and then we would hit the break statement. So we're stopping the inner for loop prematurely, but the outer for loop is not affected by that break statement because the break statement is inside the inner for loop. Versus if you have a situation like this. So now we can see that we have that if structure moved outside of the inner for loop. So now that break statement occurs inside the text or inside the body of the outer for loop. So when that condition occurs, it's going to force that outer for loop to stop, and then we would continue on with the rest of the code. Okay, so the break statement applies directly to the loop in which it resides. Okay, so the one on the left, we have the break statement is inside the inner for loop. The one on the right, the break statement is inside the outer for loop. So there's a difference in which one it's going to affect. And with that, we've reached the end of this video. So hopefully you now have a little bit of a better idea about how to use nested loops. And like I mentioned, we're probably going to be primarily using them in relation to indexing through two-dimensional arrays. But you can use them in a variety of situations. And also, hopefully you've learned a little bit about the break statement and how you can use it to stop a loop before it actually reaches its termination point.